Hello and welcome to the channel if it's your first time visit, and welcome back if you're a returning viewer. Today we're going to be doing the security footage box on TryHackMe. It's a medium box, but it's actually a very easy one to do. I really enjoyed it and I hope that you do too. So to start with, we do have only one task. We are only looking for one flag, and there is a file to download. I'm not going to expand this because I've already put the flag in. But you want to download that file, and it is a PCAP. It's going to be this file right here, security footage and a bunch of numbers .pcap. So once you got that done, you want to open up Wireshark and just drop the file in, and we are ready to get started. Now real quick, if you haven't had much of a chance to play around with Wireshark, I highly recommend going and checking out some of the rooms that TryHackMe has. I will try to find some that I would recommend, leave a link in the description to them. Great tool. I personally enjoy using it and doing data packet work with it and everything. And this one is going to be a little different from some of the others you may have come across on TryHackMe. For one, if you notice here, we have this one HTTP protocol packet. I don't know how well you can see that, but it's the only HTTP one. The rest of them are TCP, and that's a little odd. But just looking at this, the first thing that stood out to me is we have a bunch of segment packets here. And as I click on them, you look down here, you can kind of see some of the information that's going through. Looks standard. Till I get to this one, and we see image/JPEG. Okay, we're dealing with communication where images are being sent. Now, if this had been over HTTP protocol or FTP or some other protocol, we would have a much easier time extracting this, but for this one, this is where the challenge is being on TCP and not being able to use any of the tools really inside Wireshark that I'm aware of to be able to extract the JPEGs. So the easiest way to go about this is when you got one of these packages highlighted that of TCP segment of a reassembled PDU, you want to right click on it, go to follow TCP stream. This is what you should see. Now, if you've done any work with Burp Suite or any HTTP packets, you'll probably recognize this right here as a standard web GET packet, and this one would be the one in response to it. So if you're looking at burp, this would be on the left side, this would be on the right side. Then we have this boundary string information here, and then we have this JFIF. Now that rung a bell to me, and I went and pulled up one of the most useful tables I've ever come across. This right here on Wikipedia, list of file signatures. And if you can see my search here, I just typed in JPEG and takes us down here. As you can see, JFIF. That's an indicator we are dealing with JPEGs. Of course, you remember we saw that image/JPEG. And so this, which is referred to as the magic bits, is going to be very important for us. So we will keep this open and come back to that in just a moment. So how is this going to help us? Well, if you notice, we have this boundary string and the image type right there. We scroll down a bit and then we have it again. So basically what's happening is at the beginning of each image that's being transferred, we have this bit of information about the start, what it is, and the size of the image. So this is going to be very helpful in extracting the information. Now, I took a look around to see if there was any more up-to-date tools, something I would feel comfortable with recommending or showing you, and I really didn't find anything that wouldn't require a bit of work to get going. So if you know of any tool that works well with this, leave a link in the description. I'll be really happy to check it out. But for our sake here, what we want to do is go down to show data as, and you want to select raw, and then you want to hit save as, and then you want to navigate to your folder that you're doing this in, and you want to save it. Right here I've already got it saved as jpeg.raw, and you want to hit save, and you can close this. Go ahead and minimize this. And just to show you something, in case you come across this and you don't have as many packets to deal with, because you can see there's a lot of packets to deal with in this challenge. If you will go down to where you see that boundary string and the image JPEG, that's going to be the start of your image. And for this one, it's packets 8, 10, and 12 that compose the data for this first image. I'm going to show you an easy way that you can take this information and run it through CyberChef to see exactly what it is you're dealing with. So we want to right click on package number 8, go down to copy, and we'll copy as hex stream. So we'll come back to our browser, we'll open up cyberchef.io, and we're going to paste that in and scroll down to the bottom, put our cursor there, go back to Wireshark, grab the information from packet 10, copy hex stream, come back over here, paste that in, scroll down to the bottom, and get the information from packet number 12, come over here and dump that in. Now we're going to scroll back up to the top, and if you remember, there's a lot of information in front of this JFIF. And this is where that table is going to come in handy. If we look, the magic bits start with this FFD8FFEO. You can search for it, but I've gotten where I can look at hex pretty easily, and I see it's right there. So we'll just take and delete this first part. We'll come over here and do from hex, and as you can see, we see the same information we saw in that TCP stream before we set it to raw. And so all you want to do after you got this, the from hex here, is click on save output to file and just change this to 1.jpg, hit OK, and you want to save it, and then you'll see that we have the first part of an image. And you see this little broken up part here in the middle? That tells you that we are most likely dealing with JPEGs that are created from a stream. So if we didn't have a lot of packets we were dealing with, you could do this packet by packet or group by group and just extract the photos this way. But we have a lot. So how are we going to get them all out? Well, thanks to that JPEG raw file we made, we can actually make a Python script to do that for us. Put me in my VS Code over here. So I have this where it will actually just print out some information, let us know what's going on. So first just going to say this reading the file. And here we have a simple with statement. We're going to open up that jpeg.raw. And here's the key bit. Instead of just doing R for read, we're going to do RB because we want to read the bytes. We're wanting to read the raw information that's in the file. And then we're just going to read that entire file and save it into variable data. And then we're going to come down here and we're going to use the .split option. And we want to set it. Remember, since we read it as bits, we're going to use the B here for the string. And we want to split on that image/JPEG. If you're not familiar with what that does, split basically will go through a string and look for whatever it is you tell it to look for. And basically think of it like a pair of scissors. When it finds that, it cuts that string at that point. And it'll just go down the line, go through the entire string, find all those instances and cut them. And so you end up making a list out of a string. And that's what we've done here, and we've set that to parts. So in the next part, we'll just say we're processing the file, and we're going to do a for loop. We're doing for num, part, and enumerate parts. Basically what this is doing is we're telling Python we want to enumerate our list, and for each part of data in that list, each section, we want just one at a time, and we want the number of the instance. So when it grabs the first part, it puts it in here, sets this to 1. Grabs second part, puts that in here, sets num to 2. Basically, that's what it's doing. So for each part that we grab, we want to go through there and find where the first part of those magic bits, that FFD8, is, and get the number for where that is, and we're going to set that to JPEG start. Then we're going to look through part with rfind, which is reverse find, and we're going to look for this string of hex. Now, what is this string of hex? Well, come back over here to wireshark real quick. Come down here to packet 12. Remember, this was the last segment of our first image. And if you look, the last few hex is FFD9, 0D, 0A, 0D, 0A. And if you go down, you look for another ending to another image, which is simple enough. You find a starting packet, which we have here, and we have one that doesn't have that start information, and we have another one that does. So we'll go back to this one, because this and packet number 14 are both part of the same image. Scroll down, and we'll see we have the same 6 bits here at the end. So those 6 bits are an indicator to where our image ends. So it finds where this begins, and it gets that number. And if you're not familiar with what I'm saying with number, if you think of a string, say the word Python, each character is in a position in that string. So the P in Python's at position 0, Y is at position 1, T is at position 2, and so forth. Remember, we're dealing with computers here, so instead of starting at 1, it starts at 0. So what we're looking for is that position number of where this hex starts in the part string. And then we're going to do an if statement. And basically all we're doing here is we're just wanting to make sure the start value does not equal -1, because if it goes through and it doesn't find this hex string anywhere in it, it will set it to -1. And we'll do the same thing with end, make sure it's not -1, and both statements have to be true. We are going to set up a new variable, and I'll just call it a JPEG image here. We want to grab from the start position to the end position. We just want that chunk of data because that's our image. And then we're going to open up a file and folder JPEGs. So that's the folder I made here, / and I'm going to call this frame. And we're going to put the number in there, .jpeg. And here's the second key point. When you're writing out the raw bytes, you want to use WB. And we're just going to write that JPEG image from up here that we gathered the data on into that file. And then once it loops through and gets that done for all the images it finds, it'll print out saying file processed, and it'll print out the number of images it found. Okay, so here we are in the terminal. Okay, so here we are in the terminal, and I'm inside the folder that we are working in, where I've got the JPEG folder, the JPEG.raw, and our Python script here. And we're just going to use this Python 3 and run our script. And you see that went through it extremely fast and was able to get all the images, and it found 541 images. So I can't open the folder and show you, but from the one image I did show you, you can estimate that you would have to look through the images, scroll through them to actually get the flag. But remember, I said that these were JPEGs that were streamed, meaning they were captured on a camera. So how about we just turn this into a video file so you can look at the flag that way. So first thing we're going to do is change into the JPEGs folder. And then we have this command. Let me adjust this. Okay, we're going to be using the FFmpeg tool. If you're not familiar with that on Linux, that is basically the tool that allows it to handle MPEG formats, do videos and stuff like that, so you can watch DVDs. It works a lot in that field. We're going to use the dash frame rate option. We're going to set it to 25, and this is just how many frames a second you want to use. And I find for stuff like this, 25 to 30 tends to be about the best spot. Dash I is going to be used to pass in the name of the files that you wanted to grab and to use for this. And if you remember, we set the name to frame and then a number.jpg. Now since we have 541, we can't just go through here and list out each file. That would be insane. Instead, what we're going to do is use this %D, and what that tells it is look for a file that starts with the name frame, then has digits, and after random amount of digits has a .jpg, and this will grab all 541 frames. And then this last bit is the output file, and I'm just going to call it flag.mp4. So when you run it, as long as you got everything installed and up to date, it should look like this when it runs. And that's it. Now you can go inside your JPEG folder and you've got an MP4 file that actually shows you the flag. Alright, and that will be it for this room. Like I said, it's actually a simple room for a medium box, but you kind of have to understand what you're looking at inside Wireshark. Like I said, I'll leave some links down in the description for you to go get some practice with Wireshark in case you need that. If you found this video helpful, please give it a like, and if you enjoyed it, please subscribe to the channel. Thank you for stopping by, and I hope you have a really good day. See you next time.